Okay, I think today I'm going to try to figure out the spawn of our pterodactyl. Right now, he's just there on screen, and we've got the vultures turned off, but we're gonna see if we can figure out, we want to spawn the pterodactyl either on the right side or the left side, and either at, it might come from here, it might come from here, it might come from here, or it might come from here, going this way, or here, going this way, or here, going this way. So, both depending on the spawning. So this is going to be a little complicated because we need to decide the DX based on what spawn point it gets randomized to, but then also we need to spawn it only after a certain amount of time, but not only after a certain amount of time, only after a certain amount of time of not killing any other vultures. So we need to think that through, and then decide if we still want our instantiation of it to be called Self-Death Monster, or if that gives us problems. So it's a tough thing to do because I'm just a little uncertain about a couple of those things. I don't even know where to start. It's like we need to let's take a look at how our vultures are instantiated in our wave 1, right? See, this is so messy. I literally just hard-coded everything in here. We're supposed to have a spawn timer that starts at 10, which we can set that to be back to what it's supposed to be. And then it's just hard-coded every second. And a new vulture at a certain spawn zone points. Jeez, man. Oy, oy, oy. What about our vultures table? Because I know we assigned these specific ones there, but what about our vultures table in general? Vultures table. Okay. Do we get... So it looks like what's confusing to me is that we have these vulture variables, but we're not initializing these or declaring these anywhere. I guess we don't need to in a scripting language. It just seems wrong. But I guess this just means it's a local variable, and then we're moving the table, because everything in Lua is tables. So when we do an instantiation of this vulture, all it is just a table of values that we store into a variable. Then we assign that variable into the first array of our vultures table. God damn. Before I spawn vultures again. I just want to get the pterodactyl randomized first, and then we can worry about the timer, right? So, right here we instantiate a monster at a hard-coded X and Y, but we need this to be, we probably need to instantiate it with a direction as well. With a DX, rather. Yeah. Because the sprite will be flipped depending on its DX, but I would think we probably need... We'd either need to, you know, instantiate it and then manually set, hey, self.monster.dx gets whatever the appropriate DX is, or we just pass in the appropriate DX right off the bat. So, God, tricky. I guess let's do that. How about we set another parameter called dx, and we assign dx into our self dx, and then we just have to say negative 1.8 or positive 1.8 for whichever direction. So for now we'll do negative 1.8 as the dx. Let's make sure that works. And then if we pass in positive 1.8, should it be facing right? Nice. Okay. So we'll need to find... Okay. It's like we need... How do we do this? We have 3 values. Damn it. So look at this spawn zone point. Let's look at it. Let's take a look at our spawn zone point class. This is exactly what we need. We just need an X and a Y. Perfect. So we're going to do something just like this, where we're going to give ourselves a table, and we're going to hard code at the indexes the X and Y of the different values for our pterodactyl, and then we need a random... Where do we set this random spawn zone point? Vulture spawn point index. Right here. Okay. Yeah. So we would need a pterodactyl spawn point index that we set randomly, and we have to encapsulate it in a class there because the X and Y need to be tethered to one another. Is that the case? If they're not tethered to one another, we'd have to manually say a random X and a random Y, which is another way to do it. But depending on the Y decides our... No, depending on our X decides our DX. If we're spawning off screen to the left, we need to have a positive DX. If we're off screen to the right, we need a negative one. I'm just going to keep it simple the way I kind of did it like this for our vulture spawn points. So I guess I'm going to give ourselves a table called So this table of ptero spawn points, spawn zone points, that's fucking a mouthful. I'm just gonna say ptero spawn points. Just want to make sure I'm recording. So ptero spawn points is a table. And then we're gonna say there's a total of 6 ptero spawn points. So we need to insert the values the x and y values into this table of our ptero spawn points, and we need to index them, hard code them as indices so that we can randomly select from them. But you know what? Shit. It's almost like we need a dx in our spawn zone point class. Because how are we going to say... I guess we can just do a simple check. If x is less than middle of the screen, set dx to... No, but we need to pass it in when we instantiate our pterodactyl. Because the thing is, we need to incorporate the correct dx depending on the x and y, which would be nice if we had another point of encapsulation for our spawn points. So in our spawn zone points, I'm going to actually say that we have a dx that needs to get passed in as a parameter here. And I wonder if this will break. Okay, so the parameters seem to be... Actually, this isn't a good test. Let me see if once this is at 10, if it breaks once the vultures are spawned, because we use the vulture spawn point index. Okay, so it looks like the parameters can be optional, which is good. So nothing's crashing just yet. Oh, we killed the pterodactyl. Okay, so what I was testing there was to make sure that our spawn zone point didn't mess up any of our vulture spawns without passing in that third parameter. So this third dx parameter is optional, and that'll help us encapsulate the right direction for our pterodactyl spawn points. But we need a random direction for our pterodactyls. No, for our vulture spawns. Anyway, that's been a thing we have been needing to implement for a while now. But we'll get to it. So we have 6 points. 6 spawn points it could be. And we're storing at the index 1 of them. Let's go, if we do it like we read a book, right? 1, 2, 3, 4, 5, 6. We would know our x would need to be a negative pterodactyl width, which our pterodactyl width is 24, I believe. So our x for all the odds would be negative 24, while we would just have to see where the y's need to be. It would need to be like a positive 12 or something, I don't know. And then with a positive 1.8 in the dx. And what we can do here is pass all of these arguments. If I comment out our old stuff here, instantiate our pterodactyl with this spawn point 1 logic, so we can make sure it's going the right direction and spawning at the right place. Yep, perfect. So if the pterodactyl hits spawn point 1, it'll come in like that on the left, which I think is good. We can try 2 now, which will be coming from the right side. Probably at the same y, but different x, right? So we're going to be a negative dy, but we're going to be virtual width on our x coming left. And if we put in these variables instead to our instantiation, we can check. We're looking for it to fly in from the right top. Nice. So that's spawn zone point 2. We'll need which is the middle left. So our x is good to be the same, and then let's see if we just do right in the middle of our screen with a positive dx. And we give those parameters to our instantiation. So we're looking for the left middle pterodactyl to come on screen and fly right. A little too low. So we need something like okay, yeah. Oh, did you see it though? It kind of hits a weird hitbox on the I don't like that. Maybe we'll just shift it. What is virtual height divided by 3? Let me just get that number real quick. If we go to our constants, virtual height is 240. So 240 divided by 3 is 80. So let's say 85. Now it gets a different problem. That was a weird... I don't know, maybe I'm okay with that. It's just I don't like that. Yeah, we should fix that. I just don't like that wonky diagonal bounce it hits right here. Oh, it did it different. I don't know. Let's just try... Okay, I think I'm okay with that. For 0.3. So we'll put in that 75 with a positive dx as our 0.3. And our 0.4 is from the right in the middle, which should have its same y, or at least similar y, with the virtual width as the x and a negative dx. We just forgot to give it to our instantiation. And then flying in from the right. Perfect. That's great. So that's spawn zone point. That's spawn zone 0.4. Looking good. Now we need two more points. We have a 5, which is going to be 1, 2, 3, 4, 5. So bottom left. So x is going to be this. We need to guess what our y is, but it does have a positive dx. So maybe we say virtual height minus 80. I don't know. So let's see. Perfect. I think that's fine. Let's look where it comes again. Yeah, it kind of comes from the middle. Last one. So we know our x needs to be right side of the screen. We know our y can be the same, and we need a negative dx. So now I forgot to give our instantiation those values, so we can test them. And then now, cool. Awesome. Okay. So we've got, we need that to be 6. So now we've got a table of spawn zone points with appropriate dx in our indexed in our ptero spawn points table. So now, instead of initializing a monster here, oopsie, instead of initializing a monster here, well, actually, let's just to test it, we need to say how do we do this? Oh, give it a random index. Okay. So, yeah, so how we did it last time was we said I don't know if I want to put this in the init function, but I'm just trying to test it out. Self.random ptero spawn, or random ptero, god damn it, random ptero index, I'm just gonna say, and we're assigning that as math.random. Do we seed by OS time? We do. Okay. Random ptero index gets a math.random in the range of 6. So what's going to happen is every time we load the game, we're going to get a number inside this field. It's going to be either 1, 2, 3, 4, 5, or 6. And then we need to instantiate our pterodactyl based on that self. No. So we need to call the table. So we go to our spawn points, and then at the index, we fill it in with this self.random ptero index .x. And then same thing with the random ptero index.y, and then the random ptero index.dx. So if I did this correctly, every time we spawn the game, a pterodactyl should appear right away at one of the random 6 spawn points. So that was the bottom left, that was spawn point 5. That was spawn point 1. Spawn point 1. Spawn point 3. Spawn point 5. Only left side so far. Spawn point 5. Spawn point 1. Really? Oh, wow. Okay, it took like 8 tries to get a even number there. But it looks like that's working. So yeah, it's just a random spawn point for that pterodactyl. May not seem random, but that's how randomness works. Cool. So we've got the pterodactyl spawning. So now instead of spawning it here in the initialization, we need to get it working depending on the amount of vultures on screen and the amount of time. See, we gotta figure out how to do that. Because if there's one vulture on screen, if you don't collide with a vulture for 20 seconds, that's when a pterodactyl will spawn. And then if there's 3 vultures, which there is for wave 1, you have 60 seconds, 20 plus 20 plus 20. And then when that runs out, if you haven't killed a vulture, we need to spawn a pterodactyl. So we need a timer for the pterodactyl spawn that is relative to the amount of vultures that are spawned. So it's almost like, see, I don't think we need to add time to the timer every time a vulture's spawned. I think we need to just count how many current vultures are on screen at any given time and set the timer. Shit. I don't know how to do it. Because with the update function, we need that timer to be in the update function because we need to count how many vultures are there. But if we're setting the timer based on the amount of vultures, we can never decrement correctly because it's in the update function. So what do we do? Let's talk through if any time a vulture spawned, we give ourselves 20 seconds on the timer, and then we just decrement our timer in our delta time update. That if we kill one, we need to then count how many vultures are on screen. It's because one reason I'm so confused is because once we add the hatching and the upgrading of the tier system of the vultures, that's going to throw off the timer because let's say you kill one, meaning the timer would be 40, but then if you don't catch it and then it hatches, what should the timer be? Is it still counting for 2 vultures on screen or is it counting for 3? I guess I just have to decide and make that up. So what's the way to do it? You know, it's almost like, it's like we need a variable that just holds how many vultures are currently on screen. So that, oh God, I don't know. I don't know. It's a weird problem. I guess let's go with the idea that we add 20 seconds to our timer clock every time a vulture is instantiated. And then if we're lower than the timer clock for the spawn timer for our pterodactyl, after we decrement it every frame in the delta time update, that's when we spawn a pterodactyl. Now, we can't spawn a pterodactyl if a pterodactyl's already spawned. So we'll have to somehow keep track of that. Like if there is an instantiation of a pterodactyl and the timer's up, I guess if we set the timer to 0 upon spawning the pterodactyl, stop decrementing it, that could solve that. But then let's say we have 3 on screen. We kill one, meaning there's 2 on screen, meaning we get the 40 seconds until a pterodactyl spawns. But then one hatches. Should we count that towards the time? Probably not. So how do we say once we, so I guess if we have a variable that holds how many vultures are alive on screen, then anytime we collide with a vulture as the player, we just get added to our clock 20 times however many obstacles there are. And then if the timer's gone, the timer's below 0, we instantiate us a little pterodactyl. So I guess for right now, we need a couple things. We need to count how many vultures we need a vulture count, right? And it's just going to be a variable. And we need to increment that variable for every vulture that's alive. But then we need a pteroTimer. We'll start it at, I don't know, doesn't really matter, because we need to increment it anytime we've got, gosh, it's just a lot of work. Hard for my brain to stretch like this. Let's take it one step at a time here and do the vulture count. So this variable needs to hold inside it how many vultures are alive on screen, and then update if we kill vultures. So it needs to go through the update function. We can say for I vulture in pairs vultures, and vultures is our table. We can say that this self vulture count gets incremented. See, but this isn't right, actually. We need to actually say if said vulture dot exploded is false. So if not exploded, that's when we need to, because we actually populate our vultures table. Don't we populate our vultures table right away? Maybe we change that. Yeah, we did it differently. We used to have it where we spawn it right away, but now we're just manually assigning them into the vultures table depending on the wave. So if that vulture is not exploded, then that's when we increment our count. And since that's in the update loop, it'll count every vulture that's not exploded in our vultures table, which right now is hard-coded 3 of them for wave 1. And it'll update this field called vultureCount, which is just a integer that counts how many vultures are alive. So I'm going to test this vulture count, make sure it's working right. We're going to say vulture count concatenate with a string. So we're taking our vulture count integer, converting it to a string, concatenating it with this string called vulture count at x 5 y 15. So it should give us debugging for our vulture count. Oopsie. So it's just keeping on incrementing, because every single frame, it counts how many vultures are alive. So we need to flush this. No, what needs to happen here? What the heck? I get why it's doing that, I just don't know how to fix it. Because it's just counting vultures, it's counting every single vulture that's not exploded every single frame, and then it's just keeping on incrementing it. So how do we only count them once? Oy. I think we just need to set vulture count to 0 every time we're about to count, and then recount it, and then that way it'll only print the correct amount of vultures every frame, and then it'll reset it to 0 and then only count the amount of vultures that are alive. I think that's right. Yep, 1 vulture. See? Oy. Yeah. It's doing the same thing. Every vulture, it's setting this to vulture count 0. So, not quite. At every loop, we need it to stay. Yeah, every loop, not every. I think we just need to set vulture count to 0 before we count. And then loop through and iterate. And then it'll be okay. 1, 2, 3. Cool. So here's some other truth. If we kill a vulture, does it go down? Because it'll become exploded. The vulture will become exploded. Then it stops counting it. So now we've got 2. Cool. So, cool. So vulture count is looking to be working. Okay, I'm happy with that. Vulture count is working. Now we need to... We're going to use that anytime we collide with a vulture and reset our pterodactyl timer. So our pterodactyl timer starts at 1. You know, for the wave, we need to say, you know, for wave 1, at the end of our wave 1, I feel like we need to do our initialization of our timer here, vultureCount, pteroTimer. So self pteroTimer gets here instantiated at 60 because there's 3 vultures in our wave 1. And I do it here because this only runs once, so we'll initialize it. We'll initialize it correctly here, and then it'll never get touched again. And then if it's in wave 1, we say self pteroTimer gets itself minus DT, so it'll be a countdown clock. And then just to make sure that's working right, I'm gonna print pteroTimer up. So it should be 60 and countdown to 0. Well, it'll go past 0, but yeah. So we're counting that we got the pteroTimer. So what if we do where's our pteroTimer logic here? We need to say if pteroTimer if self.pteroTimer is greater than 0, that's when we decrement it. And then I kind of want to just floor the value so it doesn't have all those decimal points. Where are we rendering our pteroTimer here? So we're going to do a math.floor on our pteroTimer so we don't have those decimals. And then now pteroTimer should be 60. Nope. 13. There we go. So now pteroTimer is counting down from 60, and it should remain that way until we kill something, and then it should go to 40. Well, actually, yeah, it should go to 40. Okay. Well, so the good news is we've got the pterodactyl spawn points randomly generating. Right now we're spawning it right away, not based on the pteroTimer, but we need to adjust our pteroTimer as we collide with vultures with our vultureCount, which we also implemented today. I'm going to call that a day for today. It's because I got to wake up fairly early. But we got some stuff implemented, which is nice. If we take a get diff look, we added a parameter to our pterodactyl class. We added a parameter to our spawn zone class so that we can give that to our pterodactyl instantiation. We gave ourselves a vultureCount and a pteroTimer. We hard-coded in all the spawn points for our pterodactyl. We are currently randomly assigning our pterodactyl spawn point to be one of those X's and Y's and corresponding delta X. We are counting how many vultures are alive on screen, and we are setting the pteroTimer for wave 1 and deducting it to 0. So before I commit, actually I guess I'll leave these on for the debugging for the commit, just because I'm going to be having to test it anyway. So I'm just going to git add everything to staging area, commit with a message saying edit random spawn points for ptero, and then added timer, added pteroTimer, and vultureCount. And then we'll push that to our origin main repository and call it a day. For tomorrow it'll be, so look, actually we did this. Oh, great. Yeah, we have this hard-coded right now, but we need to fix that. So we need to say something like adjust pteroTimer upon vulture collision. Because once you hit, like, let's say you kill one vulture and there was 3 of them, if you don't kill a vulture in 40 seconds because there are 2 on screen, that's when the pterodactyl will show up. And it shows up if you kill 2 right away, you've got 20 seconds until the vulture comes up. So that should be fun. And then, yeah, once we get the pteroTimer working, which should be pretty soon, then we gotta work on the tier system of our vultures, which is something I've been putting off forever because it's complicated. But that was a good episode, and I will catch you tomorrow with some more functionality.